Did you know the sun is so big that 1.3 million Earths could fit inside it? It's the ultimate powerhouse, burning 600 million tons of hydrogen every second. That's like a million nuclear bombs going off every single second. But here's the crazy part. Even though it's been shining for 4.6 billion years, it's only halfway through its life. In about 5 billion years, the sun will expand into a red giant, swallowing Mercury, Venus, and maybe even Earth. And don't be fooled by its calm look. The sun is a raging ball of plasma, with solar storms so powerful they can knock out satellites and cause blackouts on Earth. The sun is so massive that it makes up 99.8% of the total mass of the solar system. Without its immense gravity, the planets wouldn't stay in orbit. It also burns through 600 million tons of hydrogen every second, fueling the light and heat that makes life on Earth possible. It takes 8 minutes and 20 seconds for sunlight to reach Earth, meaning if the sun disappeared right now, we wouldn't even know it until nearly 10 minutes later. The sun's surface, known as the photosphere, isn't solid, it's a swirling ocean of plasma. Above it, the corona, its outer atmosphere, is mysteriously hotter than its surface, reaching temperatures of millions of degrees. Scientists still don't fully understand why this happens. Occasionally, the sun erupts with solar flares and coronal mass ejections, sending billions of tons of charged particles into space. When these reach Earth, they interact with our atmosphere and create the aurora borealis and aurora australis, the beautiful northern and southern lights. But in extreme cases, they can also cause geomagnetic storms that knock out satellites, disrupt GPS, and even shut down power grids. The sun doesn't just give us light and heat, it also affects our weather and climate. Solar activity follows an 11-year cycle, where it moves between periods of high and low activity. During high activity, sunspots and solar storms are more frequent, affecting radio signals and even airplane communications. The sun's gravity keeps the entire solar system together, from the smallest asteroid to the largest planets. In fact, if the sun were to suddenly vanish, all the planets would fly off into space in a straight line, no longer bound by its gravitational pull. Mercury is the smallest planet in the solar system, and the one closest to the sun, even though it looks a lot like the moon with its cratered surface. It's an entirely different world, full of extremes. Since Mercury is so close to the sun, you might think it's the hottest planet, but it's not. That title goes to Venus. However, Mercury still experiences insane temperature swings. During the day, its surface can reach 430 degrees Celsius, 800 degrees Fahrenheit, hot enough to melt lead. But at night, with no atmosphere to trap heat, temperatures plummet to minus 180 degrees Celsius. One of the biggest temperature drops in the entire solar system. Mercury has one of the strangest day-night cycles of any planet. It orbits the sun incredibly fast, taking only 88 Earth days to complete 1 year. But because of its slow rotation, one full day on Mercury sunrise to sunrise takes 176 Earth days, so a single day lasts twice as long as its year. Mercury is slowly shrinking. As its iron core cools, the planet contracts, causing its surface to wrinkle and form giant cliffs called lobate scarps. Some of these cliffs are hundreds of kilometers long and rise over a kilometer high. Despite its scorching daytime heat, Mercury has ice hidden in deep craters at its poles. These regions never receive direct sunlight, so the ice stays frozen even though the rest of the planet burns under the sun's intense heat. Scientists believe this ice may have come from ancient comet impacts. Because Mercury is so close to the sun, its future is uncertain. In 5 billion years, when the sun expands into a red giant, Mercury will likely be the first planet to be engulfed and destroyed. But until then, it remains one of the most fascinating and extreme places in the solar system. Venus is often called Earth's twin because it's similar in size and composition. But make no mistake, Venus is nothing like Earth. It's a scorching, toxic world where temperatures are hotter than on Mercury, and the atmosphere is so thick it would crush a human instantly. Even though Mercury is closer to the sun, Venus holds the record for the hottest planet, with surface temperatures reaching 475 degrees Celsius, 900 degrees Fahrenheit, be hot enough to melt lead. This happens because of Venus's runaway greenhouse effect. Its thick atmosphere, made mostly of carbon dioxide, traps heat so efficiently that the planet stays scorching hot day and night, no matter where you are. Venus has one of the strangest rotations in the solar system. It takes 243 Earth days to rotate once on its axis, but it only takes 225 Earth days to orbit the sun. That means a day on Venus is longer than its year. Even weirder, Venus rotates backward compared to most planets. So if you could stand on its surface, the sun would rise in the west and set in the east, the opposite of Earth. The atmosphere on Venus is 90 times denser than Earth's, which means standing on its surface would feel like being 900 meters, 3,000 feet underwater. If that wasn't bad enough, Venus is covered in thick clouds of sulfuric acid, which create acid rain. However, because the planet is so hot, this rain evaporates before it even reaches the surface. Venus is covered in thousands of volcanoes, more than any other planet in the solar system. Some of them may still be active today, Lava flows have shaped the surface for millions of years, and recent studies suggest that volcanic eruptions might still be happening. Scientists believe Venus might have once had oceans, just like Earth, but because of extreme greenhouse heating, those oceans evaporated, and the water was lost to space. If Venus had taken a different path, it might have remained a habitable planet like Earth. Venus shows us what can happen when a planet experiences uncontrolled climate change. It was once a world that may have been similar to early Earth, but now it's an unlivable hellscape. Studying Venus helps scientists understand what might happen to Earth if greenhouse gases continue to rise. Earth is the only planet in the universe that we know for sure supports life. It's a delicate balance of land, water, and atmosphere that has allowed life to thrive for over 3.5 billion years. But despite how familiar Earth feels, there are still many mysteries about our own planet. Earth orbits the Sun at just the right distance, what scientists call the habitable zone. If we were much closer, like Venus, our planet would be a scorching wasteland. If we were farther away, like Mars, our oceans would be frozen. This perfect positioning allows liquid water to exist, which is essential for life. Our atmosphere is what makes Earth different from every other planet. It's made up of 78% nitrogen, 21% oxygen, and small amounts of other gases. The oxygen we breathe is produced by plants and microscopic organisms in the ocean. Without them, life as we know it wouldn't exist. Earth's atmosphere also protects us from deadly solar radiation and meteoroid impacts. Most space rocks burn up in our atmosphere before they can reach the ground, which is why we don't experience constant bombardment like the Moon or Mercury. Unlike many other planets, Earth is constantly changing. Its tectonic plates move beneath the surface, causing earthquakes, forming mountains, and even changing the positions of continents. Millions of years ago, all the land on Earth was connected in a single supercontinent called Pangaea. Over time, the plates shifted, creating the continents we see today. Earth is also the only planet we know of with active water cycles. Water evaporates, forms clouds, falls as rain, and flows through rivers and oceans in a continuous loop that sustains life. Deep inside Earth is a molten iron core that generates a magnetic field. This invisible shield extends into space and protects us from solar wind and cosmic radiation. Without it, Earth's atmosphere would slowly be stripped away, just like what happened to Mars. Despite everything we know about Earth, one big question remains. How did life begin? Scientists believe the first life forms appeared in the oceans around 3.5 billion years ago, but no one knows exactly how. Did life start from chemical reactions deep in the ocean? Did it come from space on a meteorite? The answer is still unknown. The Moon is Earth's only natural satellite and the fifth largest in the solar system. It has been orbiting our planet for over 4.5 billion years and plays a crucial role in shaping Earth's tides, stabilizing its climate, and influencing life. Despite being one of the most studied celestial bodies, the Moon still holds many mysteries. Scientists believe it was formed when a Mars-sized object, named Vega, collided with Earth in the early solar system. The impact ejected a massive amount of debris into space, which eventually coalesced to form the Moon. This theory explains why the Moon's composition is similar to Earth's outer layers. One of the most fascinating aspects of the Moon is that it is tidally locked to Earth, meaning it always shows the same face to us. This happens because its rotation period is equal to its orbital period, both taking approximately 27.3 Earth days. As a result, we never see the far side of the Moon from Earth. The Moon's surface is covered in craters, mountains, and vast plains of hardened lava called maria, which were formed by ancient volcanic activity. Unlike Earth, the Moon has no plate tectonics, so its surface has remained largely unchanged for billions of years. Because the Moon lacks a significant atmosphere, it has no weather, no wind, and no sound. This means that temperatures on the Moon are extreme. During the lunar day, temperatures can soar to 127 degrees Celsius, 260 degrees Fahrenheit, while at night, they can plummet to -173 degrees Celsius, -280 degrees Fahrenheit. Without an atmosphere to erode its surface, anything that touches the Moon remains undisturbed for millions of years. This is why astronaut footprints, spacecraft, and rover tracks from past missions are still visible today, despite its barren appearance. The Moon holds valuable resources. In 2009, scientists discovered frozen water in deep craters at the lunar poles. These permanently shadowed regions never receive sunlight, allowing ice to remain there for billions of years. This discovery has major implications for future space exploration, as lunar water could be used for drinking, making oxygen, and even producing rocket fuel. Mars, often called the Red Planet, has fascinated humans for centuries. It is the fourth planet from the Sun and the second smallest planet in the solar system, only bigger than Mercury. Mars gets its reddish color from iron oxide, or rust, that covers its surface. Despite its harsh environment, Mars is the most Earth-like planet in the solar system and the best candidate for future human colonization. Scientists believe Mars was once a warm, wet world with rivers, lakes, and even oceans billions of years ago. Evidence from Mars, rovers, and orbiters suggests that liquid water flowed on its surface, carving valleys and canyons similar to those on Earth. But over time, Mars lost most of its atmosphere, causing the planet to become cold and dry. Today, temperatures on Mars can drop as low as -125 degrees Celsius, -195 degrees Fahrenheit, at night, and rarely rise above 20 degrees Celsius, 68 degrees Fahrenheit. During the day, Mars has the largest volcano in the solar system, Olympus Mons, which is about 3 times taller than Mount Everest. It also has Valles Marineris, a massive canyon system that stretches over 4,000 kilometers, 2,500 miles, nearly 10 times longer than Earth's Grand Canyon. These features suggest that Mars was once geologically active, though today, it is mostly dormant. Even though the atmosphere on Mars is 100 times thinner than Earth's, dust storms on the planet can still be intense. Some storms are so large they cover the entire planet for weeks, reducing sunlight and changing surface temperatures. One of the most exciting discoveries about Mars is the presence of frozen water at its polar ice caps and beneath its surface. In 2018, scientists detected a large underground lake near the planet's south pole, raising hopes that Mars could still support some form of life. If humans ever colonize Mars, these water reserves could be used for drinking, growing food, and even making rocket fuel. Mars has 2 small moons, Phobos and Deimos, which are likely captured asteroids from the asteroid belt. Phobos, the larger of the two, is slowly being pulled toward Mars and will eventually crash into the planet or break apart to form a ring in the distant future. Jupiter is the largest planet in the solar system, a gas giant so massive that it could fit over 1,300 Earths inside it. It is the 5th planet from the Sun and is mostly made of hydrogen and helium, just like the Sun itself. Jupiter has no solid surface, only thick layers of swirling gas, and some of the most extreme weather in the solar system. One of Jupiter's most famous features is the Great Red Spot, a gigantic storm that has been raging for at least 350 years. This storm is so massive that it is more than twice the size of Earth and has winds reaching speeds of over 400 kilometers per hour, 250 miles per hour. Scientists believe the storm is slowly shrinking, but it is still one of the most recognizable features in the solar system. Jupiter spins faster than any other planet, completing 1 full rotation in just 10 hours. This rapid rotation causes the planet to have extremely strong jet streams, creating colorful cloud bands that stretch across its surface. These bands are made up of ammonia, methane, and other gases, giving Jupiter its striking appearance. Even though Jupiter is a gas giant, it may have a small, rocky core buried deep beneath its thick atmosphere. However, due to the immense pressure inside the planet, this core, if it exists, would be completely different from anything found on Earth. Jupiter has the strongest magnetic field of any planet in the solar system, stretching millions of kilometers into space. This field traps charged particles, creating powerful radiation belts that would be deadly to humans. If a spacecraft got too close to Jupiter without proper shielding, it would be fried by radiation within hours. Jupiter is often called the guardian of the solar system because its massive gravity helps protect Earth from incoming asteroids and comets. Many space rocks that could potentially hit Earth get pulled into Jupiter's orbit or are slingshotted away into deep space. Despite its immense size, Jupiter is mostly made of gas and has no solid ground to land on. Any spacecraft trying to enter its atmosphere would be crushed by the extreme pressure long before reaching the core. In 1995, NASA's Galileo probe plunged into Jupiter's atmosphere and was destroyed within an hour. Europa is one of the most fascinating moons in the solar system. It is the 4th largest moon of Jupiter and is slightly smaller than Earth's moon. What makes Europa so special is that beneath its thick layer of ice, there is a vast subsurface ocean that could potentially harbor alien life. Scientists believe Europa's ocean contains more than twice the water of all Earth's oceans combined, making it one of the most promising places to search for life beyond our planet. Europa's surface is made of solid water, ice, and is one of the smoothest in the solar system, with very few craters. Instead of impact craters, the surface is covered in cracks, ridges, and dark streaks, likely caused by the constant stretching and shifting of the ice due to Jupiter's intense gravitational pull. This process, known as tidal flexing, generates heat inside Europa, preventing its underground ocean from freezing solid. Some of these surface cracks may be linked to water plumes erupting from the ocean below, similar to geysers on Earth. One of the biggest discoveries came from NASA's Hubble Space Telescope, which detected water vapor plumes shooting up over 160 kilometers 100 miles above Europa's surface. If confirmed, this means scientists could study Europa's ocean by flying a spacecraft through these plumes, instead of drilling through the thick ice. This makes future missions much easier and increases the chances of detecting life. Europa's ocean is thought to be in direct contact with the Moon's rocky interior, which could provide the necessary chemical ingredients for life. On Earth, deep-sea hydrothermal vents support entire ecosystems without sunlight, meaning similar conditions could exist on Europa. If life does exist there, it could be in the form of microbes or even more complex organisms, similar to the strange creatures found in Earth's deep oceans. Another mystery is Europa's weak oxygen atmosphere, which is extremely thin and not breathable for humans. This oxygen is created when radiation from Jupiter breaks apart water molecules on the surface, releasing oxygen and hydrogen. While the atmosphere is too thin to support life on the surface, some of this oxygen might make its way into the ocean, potentially supporting simple organisms. Saturn is the sixth planet from the Sun and the second largest planet in the solar system, only behind Jupiter. Known for its iconic rings, Saturn is often considered the most visually stunning planet. These rings, made of countless pieces of ice, rock, and dust, stretch over 280,000 kilometers, 175,000 miles, across, wide enough to fit nearly 6 Earths side by side, but they are incredibly thin, only about 10 meters, 33 feet, thick in some places. Saturn is a gas giant, mostly made of hydrogen and helium, with no solid surface to stand on. If a spacecraft tried to land on Saturn, it would sink deeper and deeper into its thick, stormy atmosphere until it was crushed by intense pressure. Like Jupiter, Saturn has powerful storms, including a massive, mysterious hexagon-shaped storm at its north pole that has puzzled scientists for decades. This storm, which is over 30,000 kilometers, 18,600 miles wide, has been spinning for years and remains one of the strangest weather patterns in the solar system. Saturn's low density makes it unique. It is the only planet that could float on water. If a large enough ocean existed, it also has an incredibly fast rotation, completing a full spin in just 10.7 hours. Which causes its shape to be slightly flattened at the poles. Saturn was first visited by Pioneer 11 in 1979, followed by Voyager 1 and 2, but the most detailed exploration came from NASA's Cassini spacecraft, which orbited Saturn from 2004 to 2017. Cassini provided breathtaking images and valuable data, including the discovery of Enceladus water plumes. In its final mission, Cassini dove into Saturn's atmosphere, sending back data until it was destroyed by the planet's crushing pressure. Saturn's rings are not permanent. Scientists estimate that they could disappear in 100 million years as the planet's gravity slowly pulls them in. Some evidence suggests that the rings may have formed relatively recently, possibly from a shattered moon or comet. Enceladus is one of the most intriguing moons in the solar system, orbiting Saturn and renowned for its striking features and potential for harboring life. It is relatively small, measuring about 504 kilometers, 313 miles in diameter, making it one of Saturn's many icy moons. Enceladus has a smooth, reflective surface made mostly of ice, which reflects nearly 90% of the sunlight that hits it, giving it a bright appearance. One of Enceladus's most exciting features is its geysers, which shoot plumes of water vapor and ice particles into space from cracks in its southern polar region. These geysers were first discovered by NASA's Cassini spacecraft in 2005, which observed jets of water vapor, organic compounds, and other materials erupting into space. The plumes extend about 130 kilometers, 80 miles, above the moon's surface and are believed to originate from a subsurface ocean beneath the icy crust. This ocean is kept liquid due to tidal heating caused by the gravitational pull of Saturn, which flexes Enceladus as it orbits, generating internal heat. The surface of Enceladus is characterized by fractured terrain, known as tiger stripes, which are the visible cracks from which the geysers erupt. These features suggest that the moon is geologically active, with recent processes shaping its surface. The northern hemisphere of Enceladus is marked by smooth, relatively young terrain, while the southern hemisphere has more heavily cratered areas, indicating different geological histories. Enceladus has a very thin atmosphere, primarily composed of water vapor, which is continuously replenished by the geysers. This atmosphere is not thick enough to support life as we know it on the surface, but the subsurface ocean is where scientists believe the most promising conditions for life exist. Future exploration of Enceladus could reveal even more about its potential for life. While no missions are currently planned specifically for Enceladus, the data gathered by Cassini has laid the groundwork for future missions to study its icy surface and subsurface ocean in greater detail. Scientists are eager to analyze samples from the plumes, as they could provide insights into the moon's chemistry and the possibility of life beyond Earth. Uranus is the seventh planet from the Sun and is unique for its striking blue color and peculiar rotational axis. It is classified as an ice giant, a category distinct from gas giants like Jupiter and Saturn. Uranus is primarily composed of hydrogen, helium, and water, along with ammonia and methane, the latter of which gives the planet its blue hue. One of the most interesting features of Uranus is its extreme tilt. It rotates on its side, with an axial tilt of about 98 degrees. This means that Uranus essentially rolls along its orbit, making its seasons extremely unusual. Each pole experiences 42 years of continuous sunlight followed by 42 years of darkness. This unique tilt may have resulted from a massive collision with an Earth-sized object early in the planet's history. Uranus has a faint and complex ring system composed of 13 known rings, which were discovered in the 1970s. These rings are made up of small particles of ice and rock, ranging in size from micrometers to meters. The rings are dark and faint compared to those of Saturn, making them difficult to see. Uranus is home to 27 known moons, with the 5 largest being Miranda, Ariel, Umbriel, Titania, and Oberon. Uranus was discovered in 1781 by William Herschel, making it the first planet found with the aid of a telescope. It was initially mistaken for a comet until its true nature was determined. The planet has only been visited by a spacecraft once, NASA's Voyager 2, which flew by Uranus in 1986. This flyby provided the first detailed images and data about the planet, its rings, and its moons, revealing a world much more complex than previously thought. Despite its distance from the Sun, Uranus has a surprisingly high internal temperature, which suggests that it generates more heat than it receives from the Sun. This internal heat may be a remnant of its formation, and it could also contribute to the planet's dynamic weather patterns. Neptune is the 8th and farthest planet from the Sun in our solar system, known for its stunning blue color and dynamic atmosphere. As an ice giant, Neptune is primarily composed of hydrogen, helium, and water, along with ammonia and methane, which gives the planet its striking appearance. It is similar in composition to Uranus, but its deeper atmosphere contains a higher percentage of water, leading to different atmospheric behaviors. Neptune was discovered in 1846 after a mathematical prediction based on Uranus's orbit suggested the presence of another planet influencing its path. Johann Galle and Heinrich d'Arrest were able to observe Neptune through a telescope just a few degrees from its predicted position, marking a significant achievement in astronomy. One of the most remarkable features of Neptune is its dynamic weather patterns. The planet has the fastest winds in the solar system, with speeds reaching up to 2,100 kilometers per hour, 1,300 miles per hour. These strong winds create massive storms and clouds that can change rapidly. In fact, when NASA's Voyager 2 flew by Neptune in 1989, it discovered a massive storm known as the Great Dark Spot, similar to Jupiter's Great Red Spot, although it has since disappeared. Neptune has a faint ring system composed of ice particles, dust, and possibly other organic compounds. The rings are not as prominent as those of Saturn, but they are intriguing nonetheless. The rings were first confirmed by Voyager 2, which observed several narrow and bright arcs that suggest the presence of dust and larger particles. Neptune has a relatively low temperature, with average temperatures around -214 degrees Celsius, -353 degrees Fahrenheit. However, it still emits more heat than it receives from the Sun, which may be due to the slow gravitational compression of the planet over time, or possibly some unknown internal processes. Pluto, once considered the 9th planet in our solar system, is now classified as a dwarf planet. It lies in the Kuiper Belt, a distant region beyond Neptune filled with icy bodies. Despite its small size only, about 2,377 kilometers, 1,477 miles in diameter, which is smaller than Earth's moon, Pluto has a surprisingly complex and dynamic environment. One of the most fascinating features of Pluto is its heart-shaped glacier, officially named Tombaugh Regio after Pluto's discoverer, Clyde Tombaugh. This icy region is made of frozen nitrogen, methane, and carbon monoxide, and is constantly reshaped by slow-moving glaciers. Unlike many other distant objects, Pluto is geologically active, with evidence of ice, volcanoes, and a constantly evolving surface. Pluto has a thin atmosphere composed mostly of nitrogen, with traces of methane and carbon monoxide. This atmosphere expands when Pluto is closer to the Sun and freezes onto the surface as Pluto moves farther away in its highly elliptical orbit. Pluto takes 248 Earth years to complete one orbit around the Sun, and due to this elongated orbit, it sometimes comes closer to the Sun than Neptune. However, there is no risk of collision because their orbits are in a stable 2 to 3 resonance, meaning they never cross paths. Pluto has 5 known moons, with the largest being Charon, which is so big relative to Pluto that they are sometimes considered a double dwarf planet system. Charon is about half the size of Pluto, and instead of orbiting Pluto like a traditional moon, the two objects orbit a common center of gravity between them. Pluto's reclassification from a planet to a dwarf planet in 2006 sparked controversy. The decision was made by the International Astronomical Union (IAU), which redefined what it means to be a planet. Pluto failed to meet one of the 3 criteria. It had not cleared its orbit of other debris. While some still consider Pluto a planet, it remains one of the most mysterious and fascinating objects in our solar system.